Cool. Thank you, Nick, for the introduction, and Pam. I'm very, very excited to be here today, and I'm very grateful that I'm being able to give the keynote because Kotlin is something that I've grown to love over the past year and a bit. So I'm very excited to share with you the parts of Kotlin that I love, and hopefully teach you something about Kotlin, and just show you some cool features that we've used and some things that we have struggled with. So today I'm speaking about why at Over we love Kotlin and how we've used Kotlin to create a great mobile design app. And I've got a little animation heart going. Cool. So for those that aren't aware what Over is, which is probably a large majority of the audience, Over is basically a graphic design app for the everyday person. So it allows you to create like social media posters, invitations, Facebook posts, that kind of thing. And basically it's designed to be run on your phone. So we've gone with a UX approach of making sure that the app works wonderfully with just like your fingers and not designed for like your computer or anything like that. We've really taken into account like UX-wise, making sure that the app works well for you just on your phone. So this has been such a wonderful experience for me working on this app because it is such a different app from what I'm used to working on. It's got some like creative aspects, some really difficult aspects like working with graphics, processing images, that kind of thing. And even though it looks like a simple app from like just looking at the UX and that kind of thing, it's really quite complicated under the hood with what you can do with it actually when you start trying and playing around with different things. So I'm very grateful that I've been able to work on this app, but not only because of that, but because of we've been featured a few times on the Google Play Store by the Google team, just in various different categories. So when we first were launching, when we went like properly live, we were featured in the early access category on Google Play. And then we were featured when we were live, we were featured in the new apps category, which was also pretty cool. And more recently, the past few months, we've been featured in the new and updated apps on Google Play. So this for me was the first time I've had an app featured on the Google Play Store. And I feel like it's quite an achievement to have. And after a couple of years of working on Android, it's only happened to me after about 6 years of working on Android. So I'm really quite proud of what we've built at Over. It's also, funnily enough, got like quite a high rating, which I've also never had before on other apps that I've worked on. So with the new Google Play rating system, which I like, I don't know if anyone's noticed, but your ratings are a little bit higher than before. We're sitting at about a 4.6 rating on the Play Store. The older rating system, we were on about 4.3, but we're also trending, or not trending, but we're number 2 or 3, depending on the day, top grossing in art and design category on Google Play, which I feel like is a really great achievement because if you look at those other apps on there, things like Canva, Adobe Photoshop, Adobe Spark Post, some really, really nice apps. So for me, I'm really quite proud of what we've built and being able to achieve what we have. So I'm going to talk a little bit about the history of how we got to this point and some of the decisions we've made and some of the failures that we've come across. So the history of the Over app is that we started our development in about November or December of 2017. So we haven't been going for that long, especially on the Android side. The iOS app has been around for a little bit longer, but I joined the team in March 2018, and it was just 2 other people at the time that I joined, and we started, well, when I arrived, the project was already decided that we would be writing Kotlin. So you can see in this the graph of like the usage of the languages, we've got 99.4% of Kotlin usage within the app. So we're very lucky that we didn't have any legacy code to work with, so we didn't have to migrate anything from Java to Kotlin, only like new code that you maybe use from other GitHub examples or stuff like that. That's the only kind of migration that we've had to do. So what I did with this presentation is I've sort of asked my team at Over, so there's a team of about I think we have 5 people now, might be wrong, 6. But we have about 5-6 people developing, and I asked everyone what their favorite features of Kotlin were, how they felt learning Kotlin, and what their experiences and like their favorite features and the things that they thought were like a little bit tricky to learn or things that they've struggled with. So most of our experience from working with Kotlin is that we are all the team members transitioned from a Java background. So there was no one in the team that came in fresh without any Java background. So everyone kind of transitioned from the Java background, which is why I'm saying it might be a bit different for you if you've just starting Kotlin without having done Java. But our experience with transitioning was that we felt it was easy to learn as a team. So we had 2 new people join recently, and they had never written Kotlin before, and they were, within a week, they were really comfortable writing Kotlin. So we feel like it's an easy language to learn if you've got that Java background. And the one thing that we kind of noticed as a trend with it, especially throughout all of us when we started learning Kotlin, was that we started slow, right? So we just started trying to write Kotlin that would compile. So your Kotlin might look a little bit similar to your Java at first because you really come from that background. But as you get more comfortable, you start to learn about new features and start trying to use these different features in your normal work. And that I feel like is a really nice way to learn. So you don't have to learn all the language features at once. As you're going, you can do one by one and get comfortable like that. So we also felt as a team that we've struggled through some tooling things. So for instance, we've had quite slow builds sometimes, or when we first started out in 2018, we were struggling a bit with making sure KT-lint and getting all the code coverage plugins working, our build servers. And we felt that at that time, which is probably different now, we struggled a little bit more than what we would have if we were maybe just using Java. But it's not all lost. Once it was set up, we're pretty comfortable now. We've got everything working. We don't really need to adjust any of those things that are happening, especially build server configurations and stuff. Once they're set up, they're done. Okay, so I asked this question to everyone in the team if they thought Kotlin was a good choice for us as a team to have chosen. And the overwhelming response was that, yes, we love Kotlin, and Android is Kotlin first now. So everything that you see with Android and all the tutorials that are coming out from the official Android team, they have Kotlin examples, and they're really trying to push for Kotlin compatibility and really Kotlin first, sort of approaching all the new tutorials and stuff like that. And also, another thing that was a reason for us why it's a good choice is that our services team is also writing Kotlin. So they've migrated from using Java to write Kotlin, and for us it's nice to be able to read the code that they've written as it's just like what we would be writing. This would probably be true as well, I guess, for Java, because we would both be writing Java, but it's nice to know that they're also writing Kotlin. And another reality is that I think developers just don't really want to write Java anymore. At least this is how I feel in the Android community. We just, if you have a job posting and you're not mentioning Kotlin, you're probably not going to get as many people applying as what you would if you had Kotlin as your language that you use. So I'm not saying this is true for all industries. Java is still a thing and probably won't go away for a long time, but at least in the Android community, it does feel like there's more of a push for Kotlin. So I'm going to talk a little bit about some of the features we love about Kotlin and some of the lessons that we've learned whilst writing Kotlin. So the first one, and probably the most popular, is nullability. Everyone probably knows about this one, but I'm going to talk a little bit about how we've used it and why we like it. So for those that don't know what nullability is, it's basically the ability to distinguish between an object that can hold a null value and one that can't. So in this example here, you will see we have 2 variables. So the first one is var user, and then the user with the question mark at the end, and then the second one doesn't have the question mark. So the first one indicates that you can set a null value on it, and the second one you cannot assign a null value. And this helps you avoid null pointer exceptions, because everywhere in your code you have to obviously handle both conditionals, if it's null or if it's not null. Whereas in Java, you can make anything null, and then you see a lot of null pointer exceptions, and it's just not as easy to code with as this kind of nullability concept. So how do we use it at Over? Well, basically, we explicitly mark things as null when we require them, And we hardly ever use the double bang, is what's called, the 2 exclamation marks, because that basically will just produce a null pointer exception if your value is null. So we don't really use it. We sometimes use it depending on the use case, if we've already checked for null, or if we do want the app to crash if it is null, then we use it. But we don't really use that syntax. And then we use let, if, etc., all those different options to check if your value is null. So this is an example here where we use the question mark with let, and that basically, inside that block, means everything will not be null at this point. So you can then assume your user class or user value is not null. So we do this in a lot of places, but we also use if checks if we need to do the else case, that kind of thing. But we've used this quite heavily. So why do we love this feature? Well, it forces us to cater for all different scenarios. And I feel like we have a really great crash-free rate overall because of this, because of us being able to, and knowing that we need to cater for these null pointers. At previous companies that I was working at, when we would release a new feature with Java, it would be actually quite common where we would be a little bit nervous to release a feature because we weren't sure of the cases that we didn't handle. Whereas now, when we release a feature, we honestly hardly ever get null pointer exceptions. We mostly get others, other crashes that we haven't catered for. But at least, for the most part, null pointer exceptions hardly ever come about with our crash rates. So, another feature about Kotlin, the .apply method or feature. So what is .apply? So if you have a look at the definition of it in the Kotlin language, it might be a little bit confusing to understand what exactly it does. But basically, it brings the block within the variable into the this scope and returns this as the value. So that's a little bit confusing, I know. But if you look at the example, it'll probably make a bit more sense. So in this example at the bottom, I'm creating a paint object. So in Android, you get the concept of a paint object. And basically, I create a new paint object, and then I call .apply on that paint object. And then within that block, I have now got that paint object in the this scope. So if, for instance, you were in an activity and you said this dot something, you would have the activity as the this scope, right? But as soon as you put the .apply, you're changing the scope of the this value. So it can be really confusing because now at this point, you don't know which scope of this you're actually in. Are you referring to the activity, or are you within this block of the paint? So it's something that you need to keep in mind when you're using this kind of feature, and can cause some bugs. So I want to talk about how we misused this feature. So we were using this feature basically everywhere. We had huge blocks of code with using apply at the top level, and at some point further down, when you've forgotten that you've written this paint.apply, you don't know which scope you're in, right? Because now you're very far down in your code, you don't know that you're in the scope of the paint object and not the activity. So it really got really hairy to deal with and work with this feature. So I would urge you to be very careful with functions like this that change this scope of code. So one example that we had an issue with was we had a view model and an activity. The view model had a function called showLogin, and the activity had a function called showLogin. Okay, 2 same name methods, but in different classes. In our activity, we initialized the view model, and we did .apply. We were like, okay, cool, and then we had a whole block of code that was executed in the view model.apply, and then we were calling showLogin on a certain event emitted from the view model. The problem was that we had two methods with the same name, so one in the view model and one in the activity with the same name. So actually at that point, because we were in the apply block, we were calling the showLogin on the view model, not on the activity, when we actually expected the activity's showLogin to be called. And this actually caused a Stack Overflow error because the one was actually calling the other and triggering the other, and it just kept going until it crashed. So that was really fun to deal with and to figure out why this had happened, because it actually wasn't really a developer bug error. It was more like, oh, we've actually put this in a new scope, and now this is meaning something else to call show login. So I'd be very wary with using this kind of the scope of changing your this object. So what do we do now? So we use apply for initializing a variable, but not just for bringing like something into this scope. So we only really use it for like small initializations of variables that you can kind of see within itself. So like that paint example at the beginning, we still do that kind of thing because you know, like you're just initializing a variable with certain properties and then setting it to a value. You're not using it to like change the scope of your whole activity or something like that. Okay, so data classes. Okay, so data classes are basically one of my favorite features, but not as favorite as something else that I'm going to talk about next. But basically, a data class is a class that can hold data, and it automatically gives you the equals toString copy methods are automatically implemented, and you don't have to do anything. So if you add a new variable here, you won't need to you won't need to update your toString. It'll automatically do it for you. So this is an example of using it and how we've used it in our app. So you can create a text layer in the Over app, and this is kind of similar to the structure that we have, but basically you can have different properties. So we have the text of the text layer, something like the opacity, probably other things like the color, all different properties of a text layer. And we've used these kind of concepts quite heavily within the Over app. So this is an example of how we would use it, pretty straightforward from the previous slide. So we create the data classes for the text layer, and then we would just create a new text layer. So we're not in Java anymore, so we don't need the new keyword, but we create a new text layer, and because we have default parameters or default variables, see if I can get this is a bit weird. So because we have these default values set as the equals, when we create a new text layer, it'll be initialized with all these different properties that we've already set as the default. But the feature that we've used probably the most with data classes is the .copy feature. So right at the bottom, you can see we do a layer .copy, and then we change a certain value of that text layer. So we're quite heavily using immutable data classes, because if you make something mutable, so by mutable I mean you're changing your val to vars, it can be quite tricky to work with those kind of things. So we pretty normally stick to using immutable data classes throughout, because it also works well with our flows of data, which I'll talk a little bit more about later. So this is used as a fundamental part to our MVI flow. And I'm going to go quite a little bit more into this later, but just remember data classes when we go onto the MVI section later. So why do we love data classes? Well, it's a lot less code than Java, and it's just like generally less mess overall than what you would have if you have to do something with Java. And there's no need for us to implement any of those toString, hash code, that kind of thing. And no need for the builder pattern anymore. So if you're used to Java creating a builder pattern, setting certain variable values, you can now just do that with default arguments and default arguments, and only setting certain ones that you want, and named parameters. Sorry, named arguments and default values. That's what I meant. Cool. Extension functions. So what is an extension function? So basically an extension function allows you to extend a class with functionality without needing to edit the original class. So this is very good for libraries which code that you can't edit. So if you're importing a library, using something that someone else has built, it's very nice to be able to add an extension function to add functionality to these classes that you might not have access to edit. So this is an example of an extension function. We have the first line is actually just a function, and when you prefix your function name with the class name, like I've done here with Canvas, if you prefix it and then put a dot, that means you're creating an extension on that class's definition or whatever. So this example we're creating on the Android canvas. So the Android canvas doesn't have a concept of like a center point. So we created this function called canvas.center that returns a point, and it just takes the width and the height and divides it by 2. So that's quite a useful function, but it's not part of the Android APIs. And then to use this extension function, you would just call on your canvas object .center, and you would get your center points out, and then you can use that wherever you want to. So extension functions are really great, right? Everyone agrees? Yeah? Okay, so I'm going to talk a little bit about how we overuse them. No pun intended. So we basically used them everywhere. Like, we were like, whoa, Kotlin's so cool. I'm going to write extension functions for everything. Like, this is great. And this was actually problematic because we could have just created new classes and new concepts instead of creating extension functions. So it's basically what I like to call both a blessing and a curse. And you need to be quite careful when using extension functions because it's quite easy to get carried away and like really use them everywhere in your apps. So what do we do now? So we still use them, but not as much. We create new classes for our own functions, and we use extension functions on classes that aren't extendable. Or if we wanted to create like a clear separation of concerns. So for instance, if we have one module and we don't want to put like rendering logic in that module, but then in our other module we want to use classes from there but want to add some rendering logic, we might create an extension function at that point. But it's really like we'd really double think why we're doing this before we actually add these extension functions. And another thing that we do is we create private extension functions. So just adding the word private before your extension means that it'll only be scoped to your file and won't be exposed to everything else, like all your modules and everything that consumes your module or API. So what we don't do this, right? We don't use them for non-related things. So for instance, this is an example, a made-up example, where we're creating an extension function on a string object, okay? And we're saying on the string, we got a method, now we're going to make a method called toUserProperties. Seems okay, like we got a string that we want to like maybe translate from JSON or something into user properties or do something with it. But this is really, really bad because the string API should not be exposing something like toUserProperties, right? This user properties concept is part of my own logic and my class and my library that I'm creating. And if I create this extension function and ship a library with this function in, it means that everyone consuming my library will have access to this arbitrary method that is not related to a string at all, right? It's very specific to my use case. So in this case, I would rather not even have this function at all and just have the maybe constructor here where I convert the string to uppercase, right? You do not need an extension function for this kind of property logic. So what we do with extension functions is we make sure that they can actually form part of the API that you're working on or the class that you're extending, right? So this example here is a method called string.toGraphemeCharList. Okay, I probably said that wrong. But basically what this method is, for those that don't know what a grapheme, whatever I'm saying, is basically if you do on a string, if you do .toCharArray, right? Something we've done before, getting all the characters in a string, you actually get any emojis that you put in your string get chopped up into their Unicode equivalents. So if you have like a lady typing at a computer, that's actually a lady face and a computer and maybe even a skin tone. And those can actually be represented by different or more than one Unicode character. So if you do string.toCharArray, you will get all those as individual characters where you might want to get them as like actual emojis. So this method, toGraphemeCharList, is actually exposing a list of the proper emoji characters as well. So this makes sense to kind of have on a string, to extend a string API, right? Because this is something that's related to a string, it's not specific to like the context of my project, and it's probably something that we might want to use at a different point too. But maybe not even something I want to expose to other apps if there is someone consuming my API or my SDK that I've shipped to them. So maybe even we could make it private if we wanted to. Okay, sealed classes. So sealed classes are my favorite classes, and my all-time favorite feature of Kotlin. Does anyone here use sealed classes? Few people. Okay, so I'm going to talk a little bit about why I really love sealed classes, and hopefully this will get you thinking about maybe using them in your apps and how you can start modeling your stuff with sealed classes. So what is a sealed class? So I like to think of them as a more powerful enum. This is not the correct definition though. This is just what I kind of use them as, or think of them like. And basically it means a sealed class is basically only allows you to have a limited number of direct subclasses. So a little bit confusing, but anything that extends from your sealed class must be in that same file that you define the sealed class in. So this is an example of a sealed class, and an example of how we actually use it is basically one of them is this class is called add layer results, and we have two kinds of classes that extend from this add layer results. So we have an error class and we have the success class, and these are data classes just so that we can properly use them and pass them around and do comparisons and do the copy methods and use them nicely. But basically now what this means is that nowhere else can you extend add layer results. So if you have another class or another file, you can't put add layer results as the parent class. It has to be in the same file, and it has to be defined within here, otherwise Kotlin's not going to like it. Okay, so why? This is like a bit of a strange feature, right? Why would we like it so much, and why would it be Rebecca's favorite feature? So we've used it quite heavily for state management within our apps. So I'm going to get more on this later, but basically with MVI it's quite nice to use it. And it allows you to do explicit when statements to handle all of those different cases for that specific sealed class. And we've used it to represent actions within our app. So for instance, when a user clicks on a button or changes the color of a font of a layer, we have all of these represented as sealed classes that are like kind of named actions. So this is an example of how we've used it. So this is a reduce function, which you'll probably know a bit more about if you do MVI, but don't worry too much about that. But basically you can see the when statement that we've used here is basically saying when on the result object, which is the editor result, is a sealed class, we then do like basically this is a switch case in Java, so when just goes through all the different options, and we say, okay, when it is a success result, copy a certain session. When it is an error, copy the error over to the state of the class. And now with this is that if I go and add another result to that sealed class, this code won't compile anymore because I'm not handling all the cases within this when, right? So your code everywhere that accesses that sealed class will start to not compile. Okay, so why do we love them? So it makes state much easier to reason about, right? We represent everything within certain files and make sure that we've got all the different cases handled, and we'll look a little bit more at MVI now, but it ensures that we're handling all possible cases. So if we add a new state to our results or our sealed class, we will handle it. We will be forced to handle that new state. And basically we get less error-prone code because of this, right? We're forced to handle new states. We are thinking about all the different states that we have, and just generally using this a lot more to make less error-prone code. So we've talked a little bit about sealed classes, and now I want to talk to you a bit about one of my favorite topics, which is state management in a whole, like just with Kotlin and MVI and how we've done it. But it's one of my favorite things to talk about because I feel like everyone needs to do this kind of thing in any app that you build. So I feel like it's quite an important thing to get right and to try improve whatever you have currently. Okay, so keeping track of state on a screen, and what I mean by state is like what your UI should look like, right? When I talk about state, I mean, what are you displaying to your users on screen? So this can be very tricky to do, right? How do you know what state this UI is in? Is it loading? Was there an error? What is the currently selected tool in our case? Like, are you on the color tool? Are you on the mask tool? That kind of thing. And what are the properties? Like, what is the project that we're rendering on screen to the user? And on our app, especially on this screen, we have many different interactions which would affect the state of what should be shown on screen, right? We have buttons that you can do. We have gestures. We have all these different things that you can do. And without thinking about your state like as a whole, this kind of thing with pressing different buttons can get really tricky if you're handling it in the way that we used to do things, which is like with MVP or with MVVM, that kind of thing. Is this an animation? No. Yes. Yeah, so and you can see it from this example. We've got different tools that do different things, different colors that you can select. There's a color dropper, there's a shadow tool, there's filters, there's a whole bunch of stuff going on the screen. And without proper state management, keeping track of what should be displayed on screen could be really tricky without managing your state properly. So, some traditional approaches and some approaches that you might be used to using is maybe using the pattern of MVP or Model View Presenter, or more recently, maybe you're using something like MVVM to separate your logic from your UI. Hopefully you're using some pattern and you've separated your logic from your UI, because if you haven't, then you've probably got bigger problems than what I'm about to talk about. So come chat to me afterwards and I can help you with your state problems. Anyway, so let's have a look at how we would create a screen with MVVM and its potential issues. So this is something typical that I've seen in a lot of places. It's also in a lot of examples and docs that I've seen. And basically we have, for our screen, we would have like this project editor view model. And now you can see we have three different things. We have three different streams of data. One is the, am I loading something? Another one is the project that I want to show on screen. Another one is the error. Is there like something gone wrong? Did we forget to handle some condition? So these are three separate streams of data that are our UI is going to monitor, right? We've got these three things and we're going to monitor them for changes and see what we can display on screen. So this is the method to create a new project. So for instance, if you start up a new screen or something like that, we would typically, and this is what I've done before, probably a lot of you have done this kind of logic as well, is set like the loading value to true. Okay, we're starting to load a project up. Cool, we're loading. And then we go to our repository layer, we say, create this project. Okay, and then we subscribe. And now this is a background task that could happen at any time. And when it finishes, we want to set the loading to false, and we want to set the project value to the one that we've gotten from the repository, right? And the same for our error. So we want to set the loading to false, and we want to set our error value to the error that maybe happened. Maybe there was an IO issue or something. Okay, so used to this kind of logic, hopefully. Seen this kind of thing before? Awesome. So what happens when a user clicks on the project, create project, and it fails, right? We have this error state now populated. Then the user's like getting really irritated because it's not working, so they click create project again, something that you would probably do, and the error value is still populated. Cool. So now we have a loaded project because it worked, but we also have an error screen from the previous time we set that state. Okay, so this is not great, right? But no problem, we will just fix it by resetting the error value on success to null, because now we're clearing that value from the stream and the screen will be fixed, right? Everyone agrees that the screen will be fixed with this. Yeah? Yes? No? You seem doubtful? It would be fixed, right? The error would be gone and the project would be shown. But this is really, really where things start to get hairy. Haha, I rhymed and I didn't even realize. That was totally not planned. Anyway, okay, so basically this kind of thing is what causes a lot of state issues, right? When we start to now look at these values on our screen, so this is our fragment, we're now observing these three different streams of data. We want to, in the loading, we want to show or hide the loading, we want to show or hide the project, or we want to show or hide the error. So the thing that we don't know at this point is what is the overall state of the UI, right? Loading could be shown at the same time as an error on the project. We don't know, because these are all three separate streams of data. we actually don't know what the proper UI should look like at any one point in time. So this has happened to us. Happened to anyone else? Where you see something like this on screen? Where you've got like two error states and a like weird state on top? Come on, it has to have happened to everyone. Yeah. This is something that I've picked up in production about 2 weeks ago. So it's something that happens. But basically, this is a problem with MVVM. On this screen, we're actually still using MVVM, and it's something that we haven't migrated, but it's really hard for us to know at a single point in time what the UI should look like. There's no single snapshot to be able to recreate this UI from, right? Are we handling all cases? We're not. Spoiler. We don't handle this case where you don't have internet and nothing saved. And this kind of thing can pop up quite easily if you're using MVVM. Because you have to handle all these different streams of data, you get really lost in like what should I reset, what should I not reset. So I want to talk a little bit about MVI, or Uni-directional data flow. So all these acronyms, don't really worry too much about that, right? I want you to start thinking about things as like a single state that you represent on screen. Okay, no longer 4 or 5 different streams of data representing different things that are happening on screen. You have one state that you adjust based on the actions that a user is doing. So you're welcome to read more about MVI, or Uni-directional data flow, but this is a sort of, I don't want to overwhelm you too much, so don't freak out if you don't follow this too much. But basically, MVI, or Uni-directional data flow, has the concept of your view, which you're used to, and your view model. And inside your view model, you can have your processor and your reducer. But basically what happens, these are the components. What happens is on your view, you would emit different actions to the view model, right? So our actions could be something like change the color, or add a new text layer, or do something like that. And then the view model sends these actions to the processor, okay? And the processor and the reducer work together to create, skip the part about sends result, don't worry too much about that, but they work together, the processor and the reducer. They take the current state of the UI, what it looks like right now, plus the action that you've performed, producing a new state that you will then show to your users on screen. So you take your current state plus the result, and you get a new state that you show on your screen. Your view then only monitors one state action, or one observable that it needs to know about to work with, one stream of data. So this is an example of like kind of MVI. I'm skipping out a lot of parts about MVI because it can get pretty intense, and it's not the point of this talk. It's more to talk about single state and like modeling your stuff around single state. But basically we use sealed classes a lot for this kind of thing. So like I mentioned before, we have a whole bunch of actions like loading a project, adding a layer, changing the color, that kind of thing. And then we have the state. Now this state on screen is what we're going to show to users. So we want to make sure that we only ever in the loading state, or we're in an initial state, or maybe we're in an error state, right? We don't have this combination where it exists that you can show the loading at the same time as the project, or you can show the error at the same time as the project, right? And if you model your stuff around like different sort of states like this, your UI becomes a lot easier to handle, and you know exactly at what point what your UI should look like. So this is an example of using it in our view model. So now we just have one live data that we expose. So this is a stream of data that we expose to the UI, and this is our state. And on an action, so this is just the method that we call, we take the action that we get from the UI, so whatever, change the layer, added a color, whatever, and we get a result from that. So we change the project, or like update what the project should look like, and we take that result and the current state of what the UI should look like, so if it doesn't have that project loaded or anything like that, and we get a new state out of that, okay? These are the two parts that I'm not going to go into too much detail about, because this is obviously where your logic, your business logic comes in and that kind of thing. But once you've done that, you would then set the state of your stream that you're exposing to your UI, and you set it to the new state that you've just calculated from your action. Okay, so in our fragment, we would then just monitor our view model. So we would take that editor view model .state, and we would observe it for any new state that comes in. And then wherever we push a button or click something or do a gesture, we would fire off new actions to our view model. So in this example, the editor action.load project is what will be the first thing that happens when we start up the screen. So we load up the project, and the new state will then come in, and we can then use that to render what's happening on screen. So the last function is the render function, and this then goes through our state object and determines what should be visible on screen and what should be loading or what should be hidden, that kind of thing. So this way, we now know at any point in time, what the UI should look like, right? We don't have this separate stream of loading, separate stream of hiding, like there's no logic like that. It is all done within this one render function with one state to represent the whole screen. So we're much less likely to have a state where we're showing two different things, because now we've explicitly handled all three things in one render function. Cool. That was a very, very quick overview of what MVI is, but you can research more about this, and there's a lot of frameworks available already by different people. So for instance, Airbnb has exposed MVRX, Mosby is another one, Mobius from Spotify, Roxy is also one of them. So you can see this kind of pattern is used by a lot of companies, and you can also just roll your own version of this, right? If you want to, you can watch a lot of talks. There's a lot of content out on MVI, but I don't want you to worry about acronyms or anything like that, but just get your head around a single state that you're modeling, and one direction, which is why it's called uni-directional, is because it flows from the view all the way to your view model and back to your view. It's one direction that it flows. You don't have back and forth setting, getting, that kind of thing. So why do we like using MVI? Well, basically it's made it a lot easier for us to reason about states that we represent on screen. It's much less error prone for us when we add new features, because we add a new state. We then made sure that we handle that state in all different places. And it allows us, we leverage with this functionality of MVI, we leverage the data classes .copy and sealed classes quite heavily. So those concepts that we looked at previously are used quite heavily with MVI. And to be honest, I actually can't imagine what our editor would look like without this kind of state management. If we had used MVP, we would have a multitude of issues that I can just, I get scared to think about what we would have run into if we had done it that way, because you don't know what your state is. And if you're adjusting certain parts of your screen based on one little action, but you're not keeping that state anywhere, it can get really, really tough to manage and add new features to. Now with our new stuff, with our new features, we just add new actions, we just add new processes to processes actions, and we handle that new state on screen. It's a lot easier and a lot less error prone with this kind of approach. So what's not so great about MVI, right? There's always a pro and con to everything. And with MVI, there's obviously going to be a lot of learning issues and stuff like that. But we found with MVI, we get a lot more boilerplate kind of code that we have to write. So we have to write actions, results, we have to do processes and all that kind of thing to get to displaying something on screen, which maybe in some cases is a little bit of overkill, but it all has its benefits and cons. Another thing is that this could be quite difficult for newer developers. We found that it's once you understand how it works and once you've worked with it for a while, you can't stop thinking of things in that way, but it might be more difficult for newer developers to sort of get into that mode at first. Another thing is that there's also many different interpretations. So if you Google MVI, you're probably going to find 5 or 6 different ways of doing it and different names for things, which is fine. As long as you're modeling around a single state, I guess you can call it MVI. It doesn't really matter, I guess. And last point is that it might be overkill in certain situations. So in some cases, we don't use it on certain screens because it's just this screen is literally just displaying a web view with a URL, modeling a whole state and a processor and this kind of thing. A little bit of overkill, but at the same time, we've done that with a few screens, and now we're seeing weird issues on those screens. So I don't know, maybe start with the smaller one, and then as you get more states and more complex things to handle, you can look at something like unidirectional data flow. Cool. So in summary, we feel like we are very happy as a team to learn Kotlin and to write Kotlin and to use it. And we feel like it was the right tech choice. So we're very happy that we chose it, and we're very happy that we have like a 99% usage of Kotlin, and we will probably be writing Kotlin for a while going forward. We felt it was very easy to learn, and we also, obviously looking at like the not so goods, we felt like the tooling can use some improvements, but we have seen massive improvements within the past at least 2 years of working with Kotlin. We've seen some massive improvements to the tooling as we've gone. And then my personal favorite feature of Kotlin is something like CL classes, extension functions, and higher order functions. I didn't get much into higher order functions, but hopefully someone today will cover them. But a lot of our team, we work quite a bit with higher order functions and lambdas and that kind of thing. So I never knew how much I love Kotlin until I had to write Java again. So this was me, like this is a quote from me, totally legit. This is true, right? I had to write I had to write Java the other day when I was taking some library and editing some stuff in that library, and it was all in Java, and I was just like, man, I really want to write some Kotlin again. This is really not fun. But yeah, so you can quote me on that if you want. And that's all I have for you today. So thank you so much for listening. I hope you learned something.
Just before you go, we have a speaker gift.
Oh wow, thank you.
From our sponsor.
Thank you, Flat Circle.
And
sponsored. Thank you.
Should I? And for, I believe this is from you, from Pamela. So for all of the women who are presenting today.
Cool, thank you.
Thank you very much.
Thanks.
Everyone, we are running at the moment 15 minutes late. We will try to catch up, but until then, just assume you might have to add 15 minutes to the time. We're now going to split up the room in two, so choose your track, Android or else, and then we'll get set up as soon as possible.
Thanks.
Okay, thank you very much.
Cool.
Sorry, I assume those times were full.
Yeah, no, they were. I was also about on the same time there.